In this video, we're going to go through the 8.A notes on circles and ellipses. So circles and ellipses are two types of conics, which is what this unit is about. They're called conics because if you took two cones that were inverted on top of one another and slice pieces of them off, depending on how you slice it, what would be left at the top makes different shapes. So if I slice it straight across, it makes a circle. At an angle makes an ellipse, another angle makes a parabola, and then straight down would make a hyperbola. So that's where the term conics comes from, and so we're going to look at graphing two of them, a circle and an ellipse. So first for a circle, this is what the equation is going to look like. This is one with a center at 0, 0. This is what you will see more often. And the center is always going to be the opposite of these numbers that are here in parentheses. So in this example, it's x minus 3 and x plus 1. So the center is going to be the opposite, positive 3, negative 1. And then whatever is on the right side is always going to be the radius squared. So when we graph circles, the first point that we're going to graph is the center. So if I look at this one, there's nothing here, so it's going to be 0. And this is negative 1, so I'm going to go to positive 1. So my center is going to be at 0, 1, right there. And then this is r squared, so if the radius squared is 1, then the radius also has to be 1. So what that means is from the center in all four cardinal directions, so up, down, left, right, I'm going to go 1. And this will give me points on the edge of my circle, and then I fill it in. Okay, that's it for graphing a circle. So you find the center, and then use the radius to find points on the edge. So this one, again, the center is the opposite. So we have negative 3, negative 1. So my center is going to be at positive 3, positive 1. Okay, and then the radius squared is 36. So r would have to be 6. So I'm going to go from the center, I'm going to go 6 in every direction. So 1, 2, 3, 4, 5, 6, way up there. 1, 2, 3. This is going to be way off there. Off the screen probably. Alright, 1, 2, 3, 4, 5, 6. So this one is down here. And then 1, 2, 3, 4, 5, 6. So it's going to look huge because of the scale in the graph. Every other one is 1, so I have a really big circle. And that looks terrible, but you get the idea. Okay. So that's how we graph circles. All right. In addition to graphing these conics, you're also going to have to identify certain key characteristics. For a circle, it's the center and the radius. So the center is just going to be HK, which again is the opposite of those numbers in parentheses in the formula, and then the radius is R. So make sure when you're writing these that you give the center as an ordered pair and the radius as a number. Then we're going to graph an ellipse. You'll notice this formula looks a little bit different. We have fractions now. And another thing about an ellipse, it is always equal to 1. So that's one of the characteristics, one of the ways you can recognize that the equation is the ellipse, is one that's equal to 1, and then 2 that it has fractions. Okay, so let's look at graphing these. When we have an ellipse, so remember we had these numbers underneath the denominators of the fractions. If the number under x is bigger, you will have a horizontal ellipse, which means that it's bigger across than it is up. And then if the bigger number is under the y, it would be a vertical ellipse. So it's taller than it is wide. Okay, so when we go to graph these, again, the center is the opposite of what's in parentheses. There's nothing in either, there's no parentheses on either of these, so my center is going to be at 0, 0. Alright, then I'm going to use the numbers underneath to tell me the length of the different sides. So this is 16, so just like I did with the circle, it's going to be the square root, so A is going to be equal to 4, so that means it's under the X, so I'm going to go sideways, so I'm going to go right 4, left 4, so there's 2 points on my ellipse, and then for the Y, I have 4 here, so B is going to be equal to 2, so I'm going to go up 2, and down 2, and then that will give me the edges of my ellipse. So it looks something like that. Okay. This example, we have x minus 1 squared over 16 plus y plus 2 squared over 9. So again, the center is the opposite. So -1, +2. So my center is actually going to be a +1, -2, because it's always the opposite. And then here again, square root of 16 is 4. So underneath the x, that means I'm going to go right 4, 1, 2, 3, 4. And left 4, 1, 2, 3, 4. Then under the y, I have 9, so b would be 3. Square root of 9 is 3, so that means I'm going to go up 3, and then also down 3. And there's the edges of my ellipse. Okay, so let's look at key characteristics for the ellipse. Okay, the center, just like it was for the circle, it's HK. All right. It's the opposite of whatever is in parentheses. Then we have something called the major and minor axis. Okay, the major axis is the longer one. The minor axis is the shorter one. Okay, so if we look at this ellipse that we drew right here, this axis is longer, this axis is shorter. So the horizontal axis would be the major, the vertical axis would be the minor. All right. For major and minor axis, it's the equation of the line. Okay, so if it's a vertical axis, it's x equals h, whatever the x coordinate of the center is, because it has to go through the center. And then the horizontal axis would be y equals k, and so it just depends on the ellipse that you're graphing. If the x is longer, then it's this one, that's the major. If the y is longer, this one would be the major. So it just depends on the one you're graphing. So if we go back and look at this example, okay, the horizontal axis is longer, so it is the major axis. So my major axis for this graph is y equals, because it's the horizontal, and then it goes through the center, and the center is at 0, so it's y equals 0. All right, let me go ahead and write this at the top too. Our center is 0, 0. All right. Major axis, y equals 0. Minor axis is right here, so that would be x equals 0. Okay, these will always match the coordinates of your center. One will be x, one will be y. It just depends on how the ellipse is. So if this was the other way, if this was, for example, say a vertical one like that, then these would be switched. Then we also have to identify vertices and co-vertices. All right, vertices are on the major axis, co-vertices are on the minor axis, and it's just the points that we drew on the edge of the ellipse. So if we go back and look, these points right here that I drew on the major axis, those are the vertices. Okay, so my vertices are, in this case, -4, 0, and 4, 0. Then co-vertices are those points that I drew on the minor axis. So for this case, they would be 0, 2, and 0, -2. Okay, vertices are on the major axis, co-vertices are on the minor axis. Then the last thing we have to identify is something called foci. Right? It's pronounced foci, not foci or foci. Foci. It's the plural of the word focus. So if it's one, it's a focus. If there's more than one, they are foci. The way that we find them is we're going to use this formula. A squared minus b squared equals c squared. So almost like Pythagorean theorem. All right. The foci are 2 points that are inside the ellipse. All right. And they have to do with the formal definition of an ellipse. You don't really need to know this. I can explain it a lot more if you want to, but they're 2 points that are inside the ellipse, and basically if I pick a point on the ellipse and draw a line to both foci, then it makes a right triangle, and it makes the same right triangle everywhere on the ellipse. Okay, so to find the foci, I have to do a squared minus b squared equals c squared. Okay, and a and b, remember, are the numbers that are underneath the ellipse. A is always going to be the larger number. So in this case, 16, what you have to remember is these numbers are already squared, because in the equation it's a squared and b squared underneath the fraction. So they're already squared. So when you plug them in to find the foci, you don't have to square them again. So it's 16 minus 4 equals c squared. So 12 equals c squared, and c is going to be the square root of 12, which is approximately 3.4. Okay, so what that means is my foci are always on the major axis, and from the center I'm going to go 3.4 to the right, 3.4 to the left, and those x's are my foci. Okay, when you list them, so on your test, quiz, daily check, everything, it will ask you to graph them, so you need to put the x's there. It will also ask you to list them. They need to be listed as an ordered pair. So this foci is at negative 3.40. All right, and this one is at positive 3.40. So they should always be listed as ordered pairs. Okay, and that is it for circles and ellipses. So you have to graph them, graph the foci, and then make sure that you list out and be able to identify all of these key characteristics.